Hello, welcome to the Exhausted Programmer. My name is Alexander, and today we're going to be comparing some compression methods. In order to make it easier to compare compression methods, we're going to set up a script today and make sure it's available on GitHub, which you'll be able to find in the link below, so that we can run it and compare different compression methods, how long they take to run, and how big of a file they make when they're done running. In order to do this, we need to learn a few things, a few other commands such as time and disk usage, so that we can get the most from our little script, so that it has a nice clean output that is easy to read, easy to understand, and easy to customize for your own personal use. When it comes time to compare different ways of archiving your data, two main metrics come to mind that I would want to look at. How long do they take to run, and how big is the file that they give us at the end? If you're going to take these backups and transfer them to another computer in another building, you might want to prioritize smaller sizes. So let's start by trying to find a way of figuring out how big the size is of a file. There actually are many software solutions to this, but the one we're going to look at today is called DU, or disk usage is how I think of it, but the letters are just DU. Anytime you see a two-letter command in Linux or any Unix operating system, it usually means it's a really old program. I'm not going to say that's true every time, but VI instead of Vim or even ED are some really old programs that go back to the 70s and 60s. Back then, there wasn't a lot of programs to compete with, so you can have a two-name program and still be very unique. Anyway, on to DU. How does DU work? Well, here in our playground directory, we have all these files. If we want to see the sizes of the files, we can use ls, something that we're more familiar using, to see a bunch of information, including the size. Here we see it in bytes. And with DU, you can give it a specific file and see it in kilobytes. If you take this number and divide it by 1024, you get this number. If you do want it in bytes instead of kilobytes, you can give the -B flag, but we want it in what's called human readable format, so the -H. And with this, we see that CTA daily totals is 43 megabytes. We can look at other stuff here like the checklist and see that'll be around 25 kilobytes, 28, and so on. This way we can get an output of a single line of the size of the file and the file name itself. Once we have our script running, this will make it very easy to understand which file we're comparing to other files that we will run. Now that we can see the size of the file, we also want to see how long it takes to create the file. And for this, we will use a program called time. Time is pretty simple. We can give it a command like ls, and it'll tell us how long it takes to run that command. Obviously, we're going to give it the zip and compression programs, but you see that it gives us the real time, the user time, and the system time. Again, maybe for different reasons, you might want to use different ones, but I like to see the user time. The idea is how many cycles did it take, or how much time on the CPU did this specific user take to run ls. There might be other processes running on your computer that are competing for the CPU time, especially when we run the algorithms that do the compression, the programs that do the compression. They can run for a much longer time, and they might be interrupted as the CPU transitions from one process to another as its focus. So we'll get all three, but I'm mostly going to be focusing on the user for myself. But again, your own use case might be different. Time can actually give us a lot more information. If we look at our man page, we see that there is this verbose flag. But if you try to run it on ls, you'll see that it says the v command cannot be found. For some reason, well, not for some reason, there's a whole standardization with, that is written into Unix operating systems. But the simple workaround is to first figure out, which time you're running, which is the /user/min time, to go ahead and run that exactly like this. And now if we run it, we do not get the error, but instead we get all the extra information from time. This is a lot of information, and it might even be good information, but our output that we're striving for in the script will be to have only the vital information, as we will be running multiple compressions and have multiple outputs, a time and a disk usage for each one. To limit what is being put out will help us to see all the options in the outputs at the same time. On to the types of compressions that we'll be looking at. there is zip, rar. We'll be using tar to do both the GZ and XZ compressions, and we'll be using 7-zip to do just a standard 7-zip compression, and then one where we tell it to compress as much as possible. But each one of these will be ran in a similar way, and that is by seeing how long they take with time and then using DU to get the size of the file that is produced by that operation. So we need a directory to compress. So let's just do playground for now so we can get an idea, and it's not very large, so it won't take long to run. We can run zip, tell it to be recursive in case there are directories in the directory. We know it's not in this case, but for the sake of your use case, who knows? We give it the file we want to save it, and then we want to give it the directory that we want to compress. And when we do this, we get a lot of information coming out of zip. This might be useful to you, it might not. Again, we are looking to keep the information coming out small, so we can adjust it by telling it to be quiet. And that is the Q flag. Some programs you can do flags like this, some you cannot. Look at the man pages if you're having problems running things. That might be one of the problems, but for zip, this works. And instead of giving us all the output, it just gives us the file. So let's go ahead and remove that, because we don't just want the file, we want to know how long it takes to create the file. So if we do the time, we can do zip qr playground.zip and playground, and see that in order for this to work, it took, less than 2 seconds. We can, again, get more information if we did the user bin time. We'll see that, well, obviously we won't see anything because I didn't tell it to be verbose. So let's go ahead and do that here. And there we go. We see a lot more of that information, but again, more information than what I want for my script. So we won't be giving it the verbose flag. So let's write that script. Let's go into my scripts directory. We're going to call this file compare compressions. And we're going to make it easy to use on mini machines by adding this first line, the /bin/bash. Again, not needed for my own personal computer, might not be needed for your computer, but there are computers out there that will use this, and without it, it will run the script incorrectly, or it could run it in a way that is incorrect and doesn't give the standard output that we expect. We will be running basically the same thing over and over and over again with different compressions. I thought about maybe taking the time to get into functions at this point, but I think it's easier to read and easier to follow along if we just do each one individually. The first thing we might want to do is to just provide a directory name when we run the script. We've looked at in previous videos how to do this, but just so you know, we can look at anything that is given to the bash command after the command by looking at the first argument. And if we look to see if that is 0 or evaluates to 0, that means if it's an empty string, we know that nothing was provided. So we're going to give it a pretty defaulty name. And I'm going to call it data. If that is not the name of the directory you want to compress, then you need to give it a name. There are in other videos that we've discussed ways of prompting the user for that, but I'm not going to worry about that here. My suggestion is if you're going to run this on the same folder over and over and over again, just come in here, change this one variable, and now you can just run it without telling it every time what you want to compress. So it's just for ease of use in that, for that sake. We also want to know the file name, different compressions. So if it's a zip, we're going to have a .zip. If it's going to be a 7-zip file, we'll do a .7z. So we don't need to do that all here, but having just the file name without the extension can be very helpful. We can get that with this simple program called base name. We'll take a look in a second of how this exactly works. But with this command right here, we will get the file name. So let's take a look at base name. We could attempt to write our own version of base name using regular expressions, but that just opens up a whole nother can of worms for a video this short. Base name just does things that we wanted to do very simply. So we're going to give it a directory. So let's say in this case, we're going to give it playground. When we give it playground, it will tell us that the base name is playground. Let me go ahead and remove the zip just so that there's no confusion here. Again, it gives us the base name there. But you might want to run this on a directory that you give it from root. So in this case, home, username, and then playground. It will also give us playground. No slash at the end, no slashes at the beginning. It just strips all that away so that when we append .zip, as we will when we use it, I'll just say file name equals this. File name, sorry, if we echo the file name .zip, we'll have playground.zip when we do it with 7z, and that's how we will be using it in our script. So let's go back to the script, cd into scripts, and then there we go. So now let's run the compressions. The first thing is we're focusing on the output. And so to make it very clear where we're at in the output, I'm just going to put a little header, and then we can run our time zip. We're going to make it quiet, give it the file name, and give it the directory name. And there we go. And then when we're done with that, we do want to see the size of the file name. Don't forget the .zip here so that it shows us the right file. And there we go. If we save and quit, now we just need to give it a, oh yeah, I need to make it executable. Let's do that real quick. Executable for everyone, writable only by me. We can do that. Again, we can look at here to see that it did what I wanted. Now we can run this, and we can run this. It's going to take it a second. There we go. Under 2 seconds to compress the playgrounds directory into 9.3 megabytes. And it does create the file. On the GitHub in the README, there'll be an explanation as to why I'm not deleting it. But basically, I don't want to delete files on anyone else's machine. If this was only for my use, if I wasn't going to be sharing this, I would have a removal script at the end because I don't need these. But you might still want to keep them. You might want to do other comparisons between them, or whatever. I don't want to delete files off of your computer if you download and run this script. So let's delete it. And there we go. Now we just need to do that for every other version. Before we go much further with this, you might want to see the files that are being downloaded. So how can we do that? In my design of this script, I also created another variable called verbose output, which I set to false. And then we can just check to see if it's false or not here to determine what output we want to use. If it is false, or if it's true, then we want to run this line, but not quietly. Else, if it is false, we'll run the quiet version, and then we have to tell it we're done with the loop. And then for readability of the output itself, I like to have a little blank line so that it'll put a new line in and to separate the different outputs. So now if we run this, it's the same thing as before, but if we go in here, well, same thing as before, but with the extra line. If we go in here into compare compressions and we set this to true, we'll get the output like we did when we ran zip without the quiet flag, but still the same output. It shouldn't adjust too much the time it took to run. Putting stuff on the screen does take up a little bit of time, but I doubt that that's going to add many cycles to the whole process. And with that there, let's go ahead and expand the script. The different ones we want to compare. Well, first off, I don't want that verbose output every time. And we are going to do a little bit of editing. I'm not going to write the if-then statements for each one of these on camera, but I will write them after a cut. We are comparing different compressions, and I decided on 6. The next one I want to compare is RAR. A lot of people like WinRAR. This one runs a little bit differently. You have to give it the A flag to append the stuff you are compressing to a file. If the file doesn't exist, it will create it. It does have the -r flag, but this is one of those programs where you need to have all the flags separated out. You can't combine them. It says so in the man pages. I'm not just making that up. No, I did not test it out. So if it doesn't work that way, then it's just bad documentation, but I would trust the documentation in this case. This right here will put out a lot of information to the screen, but if we want it to be quiet, there's a flag called iNull that will quiet out all the output. And again, we're going to want to see the size of this. And here, with just these two examples, we can see how this compare. Oh, that is not what I meant to do. Let's go ahead and remove all the playgrounds and then run the script one more time. My problem being is I didn't tell it the directory. So zip will run under 2 seconds. RAR runs closer to 8 seconds and has a bigger file. Is that typical? I don't know. In my own testing, it felt like if it was a larger file, it ran quicker when I was comparing all these. But this is why I'm making the script. You can see for yourself, different file types compress in different ways. Depending on what you have, it might be better or worse to use different ones. Let's clean up these files. And then we can go back into this. And let's just take a quick look at the last few that we're going to run. There is tar, which will do both the GZ compression. So we give the Z flag. V will give us the verbose. So to keep it quiet, we'll take that out. File name, and it's common to give it the .tar to show that tar was ran, and the .gz to differentiate it from another one that we're going to have. And there we go. There will also be without the Z compression. So we just get the XZ compression style. So here we are compressing and we still need to give it a file name. This one will be XZ, directory name. And then we have two that we're going to be doing with 7-zip. To get 7-zip installed, there is a package you need to install. It's in the README. I think if you try to run this when you don't have it installed in your Ubuntu system, probably any Debian system, it will tell you what packages you probably want to install. So there might be a need for a little research into that. But the same is true for RAR. That was not default when I first started writing the script. Anyway, we have 7ZA. The man pages says that 7Z and 7ZA are very similar, but with the A, there's less compression versions that it's going to keep track, and therefore it might run faster. And I want to give each compression method its most likely best performance for this comparison, because if you can get a little bit more out of one just by using a different package in the full package set, might as well do that. Here we need to tell it to silence both its output and whatever P is the progress bar. This is good because both these outputs will clutter up the screen. We can give it the file name and the directory name. And then if we do the same thing, but we just give it a flag, it will give us one more option. So let's here mx equals 9. You can look at the man pages to get more. 7-zip has a lot of options that we can use, but the mx will allow us to give it the highest level of compression, at least when I was reading the man pages myself. And if we ran this, it would compress it all, but it wouldn't give us the disk usage. So I'm going to cut here and fix all that and be right back. So here we have the script fully typed out. The first part seems very familiar and the rest should look very familiar. It's just the first part, just copied and pasted and then changing the header, the actual program and flags necessary, and the extensions as well. If you know how to use Vim, there's find and replace stuff that I just can't live without. It makes this a lot easier, but we're not here to discuss Vim. So now if we run our compare compression script and we can give it this, now we can compare all of them. Again, under 2 seconds, for the zip, 8 seconds for RAR, GZ, XZ, 7-zip. And on forward, for me, it seems like XZ barely does any compression at all. In fact, we can compare how big the playground directory is compared to that 43 megabytes to see how much compression it gives us. But we have to wait for this to finish running. The 7-zip with the MX9 does take the longest, but it usually results in the smallest file. Again, depending on your need, you might want that or you might not. And there we go, 7.2. It barely reduced anything based on the default zip, but it also didn't take a whole lot more time either to run. And so how much does the playground directory use? So 43 megabytes. And so yeah, very little compression there, but this 43 comes down to 7.2 or 9, depending on which one of these versions you use. For me, like I said in previous videos, I tend to use tar and GZ. It's just habit forming. But for one of the quickest runs and pretty middling compression rate, it works pretty well for me. But how does it look on a more realistic home directory? Well, if you do not know from previous videos, I actually run Ubuntu on Windows. So I have this nice little Ubuntu on Windows operating system, which means I do actually have a Windows machine that I can access. In Bash on Ubuntu on Windows, you can access it by going to your /mount/C for your C drive users, which is now in the Windows operating systems directory setup. And we'll see here that we have a directory called AMA89, and I hate that highlighting, so I can do this. This is a directory. This is my home directory for my computer. We can run disk usage here to see the size of it. Actually, I'm going to go inside of it and then run disk usage. Max depth equals 1 is a way of just only doing the first level, but it will give you the size of the directory and everything inside of it at the same time. We want this human readable, but we also, or I don't want to output my error messages to the screen because in Windows there's an app data directory and there's a lot of permissions issues and it will just flood my screen. So we're going to send all the error messages to dev null. Then we're going to pipe this into sort, because sort will sort all this so we can see what is our biggest directories and our smallest directories, and our home directory would be the last. The problem with this is if you don't sort it, it will put out data as it's running. If you sort it, it can't put out anything until everything has been provided to sort, and sort has sorted it all. The -H here is for it to treat the strings not as strings, but to look to see if it is kilobytes, megabytes, and gigabytes in a logical progression. So 20 kilobytes will be smaller than 10 megabytes with the H, won't be without it, or at least I'm pretty sure it won't be without it. So let's run. This will take a second because I do have a rather large home directory, as we'll see in just a second. And there we go. We see that I have some empty directories. I do not use the music or I guess saved games. Downloads is actually usually pretty big, but about a week ago I spent a lot of time just deleting a bunch of files off my computer and moving them to my backup storage. Talking about backup in YouTube got me to make that push. But again, you can see just straight down that ultimately it's 74 gigabytes. So what would it look like if we compress this 74 gigabytes? Well, just like I did with the disk usage, I will make a cut after I run it. But let's go to scripts. Let's do compare, and then we can give it this command right here. And again, the base name will strip out everything but the AMA.89 or AMA89 for this. So this will work, and I'll see you when it's done. While running the compression on my entire home directory, I came to the startling realization that while I have plenty of time to let it run, I do not have plenty of hard drive space to let it run. I only have 35 gigs free on this hard drive. I use archival systems and backup systems to get stuff off this computer, so I don't need a large hard drive. And in this case, it sort of bit me. Maybe I should have ran this on one of the Linux machines I have running here, but too late for that now. I went ahead and ran it on my desktop directory, which is 541 megabytes. And so we can see based on that, these results. Also, we'll get to why XZ doesn't seem to be doing any compression, and that's my fault. But we'll get to that in just a second. If we take a look at the 7-zip MX, that's our smallest file. It did take almost 3 minutes, which is actually a little bit faster than the 7-zip by itself and a smaller file. But again, we see GZ coming in pretty good, 288 compared to 541, not quite half, but pretty good, 18 seconds. It's faster than most of these other ones. So let's fix the XZ problem and introduce a few more possible compressions. So if we go in here, the reason why it's not using the XZ is because it's not doing any compression at all. I know tar can just condense stuff down without doing any compression, and for some reason my brain just completely forgot about that when running this. To use the XZ compression, we can give it one of two flags. We can give it this XZ flag to be very verbose in our commands, or we can just give it a -J. I'm actually going to go with the --XZ because I think it's easier to read, easier to understand. But while looking at the man pages to better understand what was going on, I also saw that tar easily supports a few other compression methods that I might add to the script and run again. So now that this is here, again, I am limited on how much space I have to run, but I'll run it one more time, and then we'll see how that changes the results of the XZ. So we have here the XZ fixed. We see that it takes longer than it did before, but it actually does compress. Remember, we were looking at 541 megabytes for the desktop directory, and this gets it pretty low. Also, I let some of my old thinking stay in my head without questioning it. I said I tend to go by user. That is a very single CPU thought. If you look at real time, the reason why the real time can be less than the user is because some of these compressions can use multiple CPUs. So maybe we want to look more at the real time than the user time in our modern architecture setups. When I first got used to computers, having more than one processor was very expensive, and now you can't even buy a watch without having multiple processors in it. So do look at the time that best applies to you. System time has to do with how long the process is dealing with the system and kernel calls. Actually, that number might be relevant to you given on what you're dealing with, what kind of system you're using, and how it's set up. If dealing with the kernel is the bottleneck in your process, which I cannot imagine a scenario where that would be true for me, but it might be true for you. You might want to look at the system time. But the real time might be best, to, again, because we have multiple processors and parallelism can work. So in this case, XZ doesn't seem to have any parallel options, whereas 7-zip does. I also looked at tar's man pages and saw a bunch of different compressions and actually ran them all on desktop. I couldn't find anything that really stood out. With the runtime, I did get a few errors from some of them, but since they're not even ones that I knew about before I looked at the man pages, I didn't bother to look into them more. But you might be interested in knowing that tar has more options. We saw in a previous video, 7-zip has a ton of options. You might have to use 7Z as opposed to 7ZA to get to them, but we could go on and compare tons of different compressions. The point of this script is to make it really easy for you to just compare the ones you want to compare in a nice output. If you do want to log all this information into a file, I do need to point out, like I did with the verbose with time, you can't just do time ls and send it to a output text like you would for a lot of programs. And let me explain what I mean by that. If I do ls and I do a single arrow, it will take whatever the output of ls is and put it into the output text file. A second arrow will append if there is already something in the output file. So if I do this, nothing comes to the screen, but if I cat output, there's my ls output. But if you do that with time and you do output, it will actually assume the outputting part is part of the operation that you're evaluating, as opposed to outputting your time into the file. So first we need to use user bin time, and then you can give it an out and we're going to call this one time.txt. And then we can do ls here. The ls will come to the screen because we didn't tell it to go anywhere, but you'll see that there is now a time file, time.txt, and in it has our information that is put to that file. It looks different. The man pages will explain that better. You can format that if you want. Also for this, if I run it again, it won't append, it will just replace. If you want to append -a, and now we have two outputs. Let's go ahead and remove that real quick. If you do the A when there's not a file, it'll create the file, so you don't have to worry about that. If you want the format into something, there are options. I think it can work like this. We could do user and then a tab and then U. And now if we look at our time, all it gave us was the user because that's all I specified. But we can now do like a new line and do real \T gives it a tab, so it looks nice. And I think the E is for the real time. Now, if we look at time, we see that now our second run now has the real and the user. There's a ton of options on the formatting. And again, always look at the man pages for this stuff for more information. If it's close to what you want, but not exactly right, you can usually fix it with that by looking at the man pages. While the main topic of this video was to compare compression programs, another takeaway I hope you got from this is how easy it is to write a bash script so that you can get real information on real data and make the decision for yourself what to use in your own backing up or whatever reason you are backing up and archiving data. This code will be available on GitHub. You can find the link in the description below. If you don't know how to use GitHub, you can easily go there and just copy and paste it and run it that way. But I do plan on doing a video on GitHub and how to use it in the future. I also plan on doing a video on Vim, something else that was shown in this video. So if you have any questions about those, feel free to drop a question in the comments below and I'll address them here. And it might help me guide my video when I finally make the tutorial video on those. If you have any questions about this topic or any other topic on this channel, feel free to drop a comment below. And if you like what you see, please like and subscribe. Thank you for watching.